Welcome to EDU World Space.
We're asked to find the gravitational acceleration on Titania. So we know that for any planet, the acceleration due to gravity is just going to be the gravitational constant times the mass of the planet and divided by the radius squared of that planet. So we want to apply that to Titania. So we have g, and then they don't directly give us the mass or the radius here. They give it relative to Earth. So we could calculate what the actual values would be for that, but it'll probably be a little bit simpler to just do this kind of proportional to what the value is on Earth, which we know. So we're told that its mass is just a 1700th of what it is on Earth. So I'm going to write this as mass of the Earth over 1700. So this whole term is just the m over here. And then its radius is an eighth of Earth, so divided by the radius of the Earth divided by 8. And that whole thing's squared. So we can simplify this a little bit, and we should get g. And then I'm going to pull out the mass of the Earth and the radius of the Earth. So we'll have g mass of the Earth over radius of the Earth squared. And then the constants we're left with will be 64, 8 squared, which comes up to the numerator, and then 1700. So this whole term right here is just the acceleration due to gravity on Earth. So we know that that's 9.8 meters per second squared. So then we just multiply it by this constant 64 over 1700. And so we do that, and we get that it is 0.0377 times the gravitational acceleration on Earth, so 9.8. And so then if we evaluate that further, we'll get that it's 0.37 meters per second squared. They then ask us to find the density of the planet, and so we'll do that in a similar way. We'll just kind of compare it to the density of Earth, which they give us as 5,500 kilograms per cubic meter. So the density for Titania, like the density of anything, it's just going to be its mass over its volume. And so just like before, I'm going to write the mass relative to that of Earth. So its mass is mass of the Earth divided by 1700. We're assuming it's a sphere, so its volume is 4/3 pi and then radius cubed. So we'll do radius of the Earth over 3. Oh, whoops, radius of the Earth over 8 cubed. And when we simplify this, we should get that we get about 512 over 17. So that's 8 cubed over 1700. And then times the density of Earth. So that term is just mass of the Earth over 4/3 pi radius of the Earth cubed. So this whole thing is the density of Earth. And so now we have this relative density of Earth, and so we can evaluate that using 5,500 kilograms per cubic meter as the value for Earth, and we get 1,700 kilograms per cubic meter. So significantly less, so that probably suggests that Titania is not entirely made of rock or mostly made of rock like Earth is.